Hi students, welcome to Sunil Engineering Academy. I am Sunil, verified educator in Unacademy and also YouTube channel Sunil Engineering Academy. We have already completed Power Systems class 1, that is generating stations. In this class, we are going to learn economical operation. This is the second class. We are going to learn economical operations in this class, class 2. Okay friends, I am also taking live classes in Unacademy Plus platform. If you want access, get subscription under railway examinations with using the referral code Sunil sir. If you apply the referral code, you will also get 10% discount on that. Okay, that will be very useful for your preparation, friends. You will get interaction is the most important, friends. If you have any doubts, you can interact. Okay, and this plus subscription also useful for RRB JE CBT 2 and NTPC group D also. You can access any of the classes and from any of the educator. Okay, that is the important one. Okay, and we have already completed generation stations briefly. We don't have higher amount of time, so I am covering what are the important points. Okay, let us start, friends. If you want any PDF, that is electrical engineering PDF or electronics engineering PDF or RRB or SSC, visit our official website, that is www.sunilengineeringacademy.com. In that you will get all the PDFs. Just click on the tab RRB or RRB JE CBT 2 or SSC JE tab. You will find the PDF of electrical engineering and also electronics engineering. Okay, thank you very much, friends. And now I am moving into the class. In this class we are going to learn economical operations. First of all, what is the cost per unit per annum? Here cost is combination of fixed cost plus running cost. It is the combination of fixed cost plus running cost and divided by with total number of units generated. So we have two types of cost, fixed cost and running cost. If you want cost per unit per annum, you have to divide all the cost with the number of units generated. Then we will get the cost per unit per annum. Here what is the unit? We know very well, friends. 1 unit is equal to 1000 watt hour, or you can easily say that it is 1 kilowatt hour. Here what are the costs come into the fixed cost? What are the costs come into the running cost? This is the important one. Here fixed cost are nothing but cost of lands, buildings, real estates. That is we can say that real estate items are comes under fixed cost. Or designing, that is designing of power plant, planning, machinery, installation, all are comes under fixed cost. And salaries of higher management and interest and borrowings and group insurance and depreciation charges. It is the most important one. Depreciation charges comes under this fixed cost. Here what is this depreciation charges? That is as time increases, the cost of the system will be decreases like that. For example, resale value is decreases now. For example, if you buy a mobile with 10,000 rupees, after 6 months, if you want sell this mobile, we can sell this with only 5,000 or 4,000 rupees only. Okay, that means the cost will be decreases. In the same way, the plant, if the lifetime of plant increases, then the charge may be, then the cost of the system may be decreases. Okay, so that is comes under depreciation charges. So these depreciation charges are comes under fixed cost. It is most important one. And the second one, running cost is nothing but fuel cost or any raw material for generation, any raw material for operation or generation, and causes and wages of labor and salaries, that is operating staff or salaries and supervising maintenance and all repairs, all these all comes under running cost. These all comes under running cost. Let us take by use with example of mobile. If once we buy the mobile, that is we can say that it is a fixed cost. After that, operating cost is nothing but recharges, top ups or data packs, all are comes under running cost. Okay, in that way we can understand. Now we are going to learn different types of factors. These are very important. Load factor, diversity factor, plant capacity factor, plant utilization factor. These are very important. These are used for helping the minimization of the cost. How they are affected, we are going to learn how they are uh, affected for generation of that is the cost of the system. First of all, before going to that factors, we are going to learn some important terms. What is connected load, what is installed capacity, what is maximum load, and what is reserve capacity. First of all, what is the connected load? Connected load is nothing but it is sum of the power ratings of electrical appliances. It is arithmetic sum of power ratings of electrical appliances. That means, for example, in our house we have three fans and one AC, and one washing machine, one motor, like that. Here these ratings, the ratings of all these equipments in our house, we can say that connected load to our house. In the same way, if the power system having the loads, the sum of all the loads connected to the power system is called connecting load. So connected load to the power system is sum of all the equipments of power ratings, that is ratings of the equipments. And what is the installed capacity? Installed capacity is nothing but in power systems, in power generating station, if we have three generating stations, that is three generators, that is, let us take here one is 210 megawatts, here one is 210 megawatts, here other is 210 megawatts, like that. Here the installed capacity is nothing but arithmetic sum of all the ratings of generators, friends. All the ratings of generators is nothing but installed capacity. And what is the maximum load? For example, if you take any of the power station and the loads which is higher, that is highest point of the load is nothing but you can say that maximum load. So in this load, the consumers consumes highest power, so you can say that it is highest amount of power that can be consumed by the consumer at any instant of time over the specified period. For example, if you take one daily load car for 24 hours. In this 24 hours, for example, let us take here, this is the maximum load. Let us take 100 megawatts, like that. Okay, this is the maximum load. Okay, that is here the highest amount of power that can be consumed by the consumer, but at any instant of time over the specified period is nothing but maximum load. Here generally what happens, friends? Here this maximum load always less than the installed capacity. This maximum load always less than the installed capacity. Then only the system will be stable. For example, if we are the installed capacity with 210 megawatts, then the maximum load is 230 megawatts. Then what happen? There is a failure of grid. That means the system will be unstable. Okay, unstable. But for example, if a man can weight 50 kgs, if we put 100 kgs on 100 kgs, then he cannot bear. In that way, the installed capacity must be higher and the maximum load of the system must be lower, then only the system will be stable. So we have to design the installed capacity by the sense of maximum load. So here design is like that, installed capacity must be greater than that of connected load and maximum load, maximum load. So we can say that maximum load helps in determine the size and cost of the installation. It is the important one. Maximum load helps determining the size and cost of the installation. And another important one in this economical operation is reserve capacity, friends. What is this reserve capacity? That is installed capacity minus maximum load. Installed capacity minus maximum load is the reserve capacity. Whenever this reserve capacity is positive, positive means installed capacity is higher, then only it will be a positive, na? Then it will be a stable. If the installed capacity is lower than this maximum load, then it will goes to the unstable, friends, unstable. Okay. And the next one, the definitions. These are very easy definitions. You can easily get these definitions. These are very easy. I think no need of explanation, but I will give a small introduction. Average load. Average load is nothing but number of units generated by total number of hours in a specified period. Specified period. For example, if they will give daily, we have to select it 24 hours. If they will give annually, we have to select it for this select for this annually, that is 365 days into 24 hours, like that we have to select like that. Okay. And firm power, cold reserve, hot reserve. Firm power is nothing but it is the amount of power available during emergency condition. The power available in emergency condition is nothing but firm power, firm power. And what is the cold reserve? The amount of power available for reserve, for service, that is any maintenance or any repair, but not operation, it is available for service only, for maintenance purpose only, for repair purpose only. That is power is nothing but cold reserve. And what is the hot reserve? The power available for operation but not service, is nothing but hot reserve. And what is the spinning power? The spinning power is power available at the bus bar. At the bus bar is nothing but it is spinning power. Okay. Spinning power. Okay. And no need of in detail explanation, friends. You have to remember that. Okay. If you want this PDF, you can download from our website, that is www.sunilengineeringacademy.com. And the next one, load factor. It is the most important one. Load factor or plant load factor. You can say that PLF. PLF. Okay. And in this, what is this load factor? Load factor is the ratio of average load by maximum load. Average load by maximum load. What is this average load? Average load is nothing but number of units generated by total number of hours. So we can say that actual number of energy generated by total number of hours. We can replace this. Okay, then we will get this formula. And here we know that maximum load is always higher than this average load, na? Maximum load is always higher than this maximum load, na? Then denominator is higher means what is the load factor? It will be less than 1. It will be less than 1. So load factor is always less than 1. Is always less than 1. And this load factor is mainly used to minimize the cost of energy. That is minimize the cost of energy. That is as PLF is higher, then what happen if load factor is higher, then higher amount of, that is the load will be, the average load will be high. Average load will be high. That means the number of units generated will be high. If the number of units generated are high, then the cost of the system will be, that is cost of the unit will be decreases. That means whenever there is a high amount of load factor, then cost will be decreases. For example, if the load factor is 80%, then we can say that it is economical. Okay. And the next one, running cost. Here it is the most important one. Here higher number of energy units generated means higher units generated for the same fuel, for the same amount of fuel. Then what happened? Here the running cost will be decreases, na? With the same fuel, we get higher number of units generated means the cost, that is running cost, will be decreases. That means plant load factor is high, it reduces the running cost, it reduces the running cost. Okay, and the next one, diversity factor. Diversity factor is equal to arithmetic sum of maximum loads by sum of the maximum load of the, that is simultaneous maximum load of the system, that is the maximum load of the power station, maximum load of the power station. We know that the arithmetic sum is always higher, na? The arithmetic sum is always higher. That means the numerator is higher, means the denominator value is higher, that is greater than 1. So this is very important, friends. Diversity factor is always greater than 1. And whenever this diversity factor is high, the cost per unit is decreases. Which cost? Here it depends upon, it is nothing but fixed cost. For example, if the diversity factor is higher, then we can say that maximum load of the system is low. If it is higher, then maximum load of the power station is low. If the maximum load of the power station is low, then we can get the installed capacity is low. So if the installed capacity of the generating station is low, then the cost of the system will be decreases. Okay, that means we require very less amount of installed capacity. If the diversity factor is high, we require very less amount of that is rating of the generators, installed capacity of the generator. Okay, that means the cost of the initial cost will be decreases, that is fixed cost will be decreases. Okay, so here the diversity factor is higher means the fixed cost of the system will be decreases. Important, friends, diversity factor, fixed cost, it decreases the fixed cost. Okay, and load factor, if load factor is high, the running cost will be decreases. Okay, and the next one, plant capacity factor. PCF, it is average load by installed capacity. We know that load factor is equal to average load by maximum load. For here plant capacity factor, here remember that capacity C, here also you will get installed capacity, like that you have to remember. PCF, that is capacity factor. Here it is based on installed capacity. We know that maximum load is less than installed capacity. We know that maximum load is less than installed capacity. That means installed capacity is higher than this maximum load. That means here the denominator is higher, then what happen, we can say that average load, here average load is less than this installed capacity. So plant capacity factor is always less than 1, and also installed capacity is higher than this maximum load. We know that load factor is equal to average load by maximum load. Here average load by installed capacity, here installed capacity is higher means the capacity factor is lower than that of load factor, na? Okay, here let us take load factor is equal to 10 by 5. Okay, and capacity factor is 10 by 8. Which is higher, friends? Now which is higher? Load factor is higher, na? So I am also giving the same, relation. Here the denominator is higher in capacity factor, that is installed capacity is higher, so we will get less PCF. Here denominator is lower than the installed capacity, so we will get higher LF. So that's why PLF is greater than PCF, or PCF is less than PLF, like that. Okay, so in that case only we will get the reserve capacity as positive. And one more thing, friends, if you take this PCF by this PLF, we know that PCF is average load by installed capacity, PLF is average load by maximum load, then average load is cancelled, then we will get maximum load by installed capacity. This is nothing but plant utilization factor. So we have here PCF by PLF is equal to PUF. This relation is very important, friends. But how to remember this one? This is if you don't know these formulas, to remember this is somewhat difficult. Okay, so to remember this one, I have one trick, that is LUC, luck, LUC. You can say that law is one term, Q is one term. Okay, so LU is equal to C. You have to remember this one. LU is equal to C, that is PLF into U means PUF is equal to PCF. In that way you can remember the relation. Then you won't forget, friends. Okay. And the next one, plant utilization factor. This plant utilization factor is nothing but maximum load by installed capacity, or we can also say that actual energy generated by installed capacity into actual number of hours that plant is used. That is nothing but utilization factor. Okay, I have given the trick also here. Here another important points on this are the selection size of the unit. Selection size of the unit is based on PUF, and optimum generation capacity which is to be added based on PCF, friends. Capacity based on capacity factor. Okay, in that way you can remember. And demand factor is equal to maximum load by connected load. And what are the effect of this load factor and diversity factor? As load factor and diversity factor increases, then cost of the system will be decreases. This is the relation. Okay, and some simple problems, friends. I have given these simple problems in PDF. In this PDF, these are very simple problems. Okay, and load curve. We know the load curve. This is the load curve, that is a representation of the load in the time. And load duration curve is nothing but in descending order. Arrange the order in descending order of magnitudes. Okay, and the next one, what is base load and what is peak load, we have already discussed. Here I have given some important base loads and peak loads, and that is plants. Here the non-conventional plants are peak loads, friends. Non-conventional plants are peak loads except geothermal. So that's why this is the most important one. Geothermal is the worked as base load. And conventional, all the conventional source, here diesel will be used as peak load plant, gas peak load plant, and hydel will be used as the both base and peak load. It without pondage it act as a base load. With pondage it can be act as a peak load also. Thermal and nuclear power stations are base load plants. And tariffs are may not be important, friends. I have given all the details in PDF. Okay, black rate PDF, two part tariff PDFs. Okay, here the important one, in case of industries they are using two part tariff. This one is only important, two part tariff. Okay, and power factor tariffs. Okay, friends, we have completed the economical operation in power stations. In the next class, we will discuss the remaining topics, that is our transmission and distribution basics. Okay, if you want the PDF, visit our website sunilengineeringacademy.com and download the PDF. We have very less time, friends. This PDF is mostly useful for your preparation. Okay, don't waste time and utilize the time effectively. Okay. Okay, friends, thank you very much.